Deep below the sunlit ocean, survival is a ruthless science. Creatures wield transparent skulls and blue blood, mastering darkness with adaptations so bizarre they threaten the entire balance of the sea. But dominance here isn't about size. It is about evolution's most unsettling experiments competing for control. What makes these 10 deep-sea monsters so powerful that they could change the ocean forever? And where do we start unraveling their true hierarchy? In the dim twilight zone, where sunlight fades to a pale blue haze, survival depends on seeing what others cannot. Here, the Barreleye fish drifts in near silence, its body just a shadow among drifting plankton and the faint outlines of siphonophores. At first glance, the Barreleye seems almost unearthly, a small fish barely 15 centimeters long with a head so clear it reveals the machinery of its own vision. Inside this transparent dome, 2 green, tubular eyes point straight up, fixed on the faint glow that filters down from above. These eyes aren't just for show. They are built for a world where light is measured in single photons, where the difference between life and death is the ability to spot a meal or a threat before it is too late. The Barreleye's dome is more than a window. It is a shield, a lens, and a light funnel all at once. Made of dense, collagen-rich tissue, the dome is filled with fluid, matching the refractive index of seawater. This means light passes through almost undisturbed, giving the Barreleye a perfect view of the world overhead, while protecting its sensitive eyes from the stinging tentacles of siphonophores, its favorite prey. Jellyfish fragments have been found in the stomachs of captured barreleys, proof that this fish is a specialist in hunting among the drifting colonies of the deep. The real marvel lies in how those eyes work. Unlike most fish, the Barreleye's eyes are long, narrow tubes, each packed with rods tuned for the faintest glimmer. By default, they point straight up, scanning for silhouettes of zooplankton and jellies outlined against the last threads of daylight, but the eyes do not stay fixed. Supported by specialized muscles, they can rotate nearly 180 degrees, swiveling forward to track prey that comes within striking distance. This gives the Barreleye a field of view that few other animals can match, combining the precision of binocular vision with the ability to sweep the darkness for any sign of movement. Scientists studying related species have found that this tubular design narrows the field of view to a tight cone, less than 50 degrees, maximizing sensitivity to light directly overhead. With rotation, the Barreleye can widen its gaze, switching from passive scanning to active pursuit in a heartbeat. The retina is dominated by rods, not cones, pushing the limits of low-light vision. Some researchers believe the green pigment in the eyes acts as a filter, sharpening contrast and helping the fish distinguish between real prey and background bioluminescence. Every detail of the Barreleye's anatomy is tuned for the twilight. Its gelatinous body floats with minimal effort, conserving energy in a world where food is scarce. The transparent head is not just camouflage, but a functional adaptation, allowing the eyes to gather and focus every available photon. In the quiet battle for survival, seeing first means eating first, or not being eaten at all. The Barreleye fish, with its glassy skull and swiveling gaze, stands as proof that in the deep sea, true dominance begins not with teeth or speed, but with the power to see through darkness. In the deep, far below the reach of sunlight, survival is a matter of extremes. 2 creatures, one draped in velvet black, the other stretched into a living trap, have mastered the art of waiting. The vampire squid and the gulper eel stand as proof that in a world of scarcity, endurance and adaptation can be just as powerful as brute force. The vampire squid, Vampiroteuthis infernalis, lives in the oxygen minimum zone, where levels drop so low that most animals suffocate. Instead, it thrives. Its blood is not red but blue, thanks to a copper-based molecule called hemocyanin. This binds oxygen more efficiently than hemoglobin, pulling what little air exists from the water. The vampire squid's metabolism runs in slow motion, burning energy at rates among the lowest ever measured for a cephalopod. It doesn't chase prey. Instead, it floats in the gloom, unfurling delicate filaments to snare drifting detritus, dead plankton, fecal pellets, and marine snow. When threatened, it doesn't squirt ink, but a glowing cloud of bioluminescent mucus, confusing predators and buying precious seconds to slip away. Its name conjures horror, but its strategy is pure pragmatism: survive by doing less for longer than anything else around. A few hundred meters away, the Gulper eel waits in the same black water, but with a different plan. Its body is thin and whip-like, tapering into a tail tipped with a glowing lure. The real marvel is its jaw. When closed, the mouth looks almost dainty, but when a shadow passes close, the eel's jaw unhinges and balloons outward. This mouth can expand to swallow prey nearly as large as the eel itself, up to 10 times its own body mass. Elastic ligaments and a loosely hinged skull allow the Gulper eel to engulf entire shoals of shrimp or fish in a single gulp. The jaw volume expands by a factor of 20 or more, a feat unmatched by any other vertebrate. Once the meal is inside, the eel's stomach stretches to match, storing food for weeks or even months. In a place where the next meal might never come, this is the ultimate insurance policy. Both the vampire squid and the Gulper eel are masters of energy management. One hoards every molecule of oxygen, the other hoards every calorie. Their bodies are built for endurance, not pursuit. The vampire squid's thin, gelatinous flesh is nearly neutrally buoyant, letting it hover without effort. The Gulper eel's muscles are weak, its bones sparse, but its jaw is a spring-loaded trap, always ready. Neither animal wastes energy on unnecessary movement or aggression. These are not hunters in the classic sense, they are minimalists and maw masters, thriving by exploiting the rarest resources and waiting longer than their rivals. Their strategies set the stage for what comes next, creatures that will take these lessons of patience and transform them into weapons, turning light and energy into tools for attack. But in the silent dark, the first rule is always the same: endure, adapt, and never waste what little the deep sea offers. In the deep sea, light is more than a beacon, it is a weapon. The dragonfish and the anglerfish have turned bioluminescence into a hunting strategy so precise it borders on invisible warfare. Every night, as billions of small creatures migrate upward in search of food, these predators wait in ambush, armed with light that few can see and even fewer can escape. The dragonfish is a master of covert illumination. Unlike most deep-sea animals which produce blue or green light, the dragonfish wields red bioluminescence. Its suborbital photophores emit light at wavelengths above 650 nanometers, reaching into the far red spectrum well beyond the vision of most marine life. This is not an accident of chemistry, it is an evolutionary arms race, a private waveband engineered through a two-step process. Blue light is produced, then absorbed by specialized pigments and re-emitted as red. The result is a searchlight that reveals prey without alerting them. To see its own light, the dragonfish has evolved a visual system unlike any other. In genera like Aristostomias and Pachystomias, 3 separate opsins tune the eyes to longer wavelengths, picking up the dragonfish's secret signal. Malacosteus, the loose-jawed dragonfish, goes even further, incorporating a chlorophyll-derived photosensitizer, likely stolen from its diet of copepods, into its retina. This pigment acts as an antenna, capturing red photons and funneling energy to the visual pigments. No other vertebrate is known to use this trick. The effect is simple. Dragonfish can hunt with a spotlight that makes their prey glow while remaining invisible to everything else in the water. The dragonfish's barbel, a thin filament trailing from its chin, is more than just a lure. Laced with adrenaline-sensitive tissue, it can pulse with light on command, drawing in small fish and crustaceans. When a target approaches, the dragonfish strikes with needle-like teeth and a jaw that opens wider than its own head. Stomach contents reveal a diet heavy in lanternfish and shrimps, creatures that never saw the red light coming. The anglerfish, meanwhile, takes deception to another level. Its esca, a glowing bulb at the end of a modified dorsal spine, houses colonies of symbiotic bacteria. These bacteria produce blue-green light through a chemical reaction involving luciferin and luciferase, fueled by oxygen. The anglerfish can control the glow by regulating oxygen flow, switching the light on or off as needed. When prey is near, the anglerfish flicks its lure, mimicking the movements of a tiny worm or shrimp. Drawn by the promise of an easy meal, small fish swim close, too close. The anglerfish's jaws snap shut, trapping prey in a mouth lined with inward-pointing teeth. Both the dragonfish and the anglerfish thrive in the vertical migration zone where prey density surges each night. Their success depends on more than just light. Dragonfish eyes are packed with red-shifted rods, fine-tuned to detect their own emissions. Anglerfish rely on a keen sense of water movement, detecting the faintest vibrations from passing animals. Each has turned the darkness of the deep into an arena of sensory advantage, where the ability to see or lure in total blackness means the difference between feast and famine. In these depths, light is currency, and those who wield it with precision rule the shadows. The dragonfish's invisible laser and the anglerfish's living lantern are not just curiosities, but the sharpest blades in the silent arms race of the deep. Beyond the twilight zone, where the last threads of sunlight vanish, the ocean tightens its grip. Here, more than a kilometer beneath the surface, two sharks prowl in silence, relics of an ancient design, perfectly adapted for ambush in the perpetual night. The goblin shark and the frilled shark are not hunters of light or illusion. They do not lure, they do not glow. Instead, they strike with mechanisms forged by pressure and scarcity, relying on skeletal innovations that turn patience and precision into deadly force. The goblin shark, Mitsukarina ostoni, is a living fossil. Its lineage stretches back 125 million years, unchanged by the passing of continents or the rise and fall of surface predators. It drifts slowly, pale and soft-bodied, with a long, flattened snout that bristles with electroreceptors. In these depths, speed is a luxury few can afford. The goblin shark's answer is a jaw that does not just open, it launches. When prey wanders too close, the lower jaw rockets forward at a speed of 3.14 meters per second, covering up to 9% of the shark's body length in a single strike. This extension is powered by elastic ligaments and loose cartilage, creating a slingshot effect that outpaces almost every other fish. The mouth gapes to 111 degrees, revealing rows of needle-like teeth. In less than a third of a second, the jaws snap shut, grabbing squid, fish, or crustaceans before they know what happened. High-speed video from Rare Encounters shows the goblin's jaw shooting out nearly as far as its snout, then retracting just as quickly, leaving nothing but drifting debris in its wake. The frilled shark, Chlamydoselachus anguineus, is another survivor from the deep past, often called a living fossil for its eel-like body and primitive features. Unlike its cousin, it does not rely on speed or sudden movement. Its secret lies in its gills, 6 pairs, each edged with frill-like margins that ripple in the current. These gills may provide extra surface area for oxygen absorption, a critical advantage in water where every molecule of air is precious. The frilled shark's body is built for stealth and endurance. Its long, flexible spine lets it coil and strike like a snake, lunging forward to seize prey with backward curving teeth. The teeth are arranged in 25 rows, designed to trap slippery fish and squid. Once caught, escape is nearly impossible. The frilled shark's muscles run the length of its body, allowing it to twist and constrict, swallowing prey whole, even those nearly half its own size. Both sharks haunt the midnight zone, a realm defined by pressure and darkness. Here, bioluminescence fades and the rules of the hunt change. Ambush replaces pursuit. The goblin shark's slingshot jaw compensates for its slow, energy-saving drift. The frilled shark's gill frills and muscular body make it a patient, tireless stalker, able to wait out its prey for hours or even days. Neither relies on light, neither needs speed. Their strength is in skeletal innovation, a mastery of mechanics that lets them survive where almost nothing else can. In these depths, the power to strike without warning and to endure without rest defines the true rulers of the dark. The goblin shark and the frilled shark are reminders that in the deep sea, the old designs are sometimes the most effective, and that evolution, given enough time and pressure, can turn patience into a weapon. At depths where pressure would crush most lungs, the sperm whale glides with purpose, carrying the legacy of the ocean's most relentless hunter. Its body is an archive of the battles fought in darkness, etched with circular scars, each one a record of struggle against colossal prey. These rings, pressed deep into the whale's skin, match the diameter and pattern of giant squid suckers. Some scars are fresh, pink against slate-gray skin. Others have faded, layered over decades of pursuit. For scientists, these marks are more than curiosities. They are physical proof of an arms race playing out in the abyss. The evidence does not stop at the surface. Inside the whale's stomach, researchers find the beaks of giant squid, tough as horn and undigested by even the whale's powerful acids. Each beak is a signature, confirming that the whale's dives are not idle wanderings but calculated hunts. Some whales carry hundreds of beaks, ranging from the delicate jaws of juveniles to the massive razor-edged weapons of adults. In some cases, the size and shape of these beaks hint at encounters with even larger, more mysterious squid, creatures that may never be seen alive. Surviving these battles requires more than brute strength. The sperm whale's physiology is built for the hunt. Myoglobin-packed muscles store oxygen for dives that last up to 90 minutes, allowing whales to reach depths beyond 2,000 meters. Their rib cages collapse under pressure, lungs compress, and the heart slows to a crawl, conserving every molecule of air. This suite of adaptations turns the whale into a living submarine, capable of patrolling the deep for hours at a time. Every scar, every beak is a testament to the whale's dominance. No other predator leaves such a clear forensic trail or claims such formidable prey. In the hierarchy of the deep, the sperm whale stands at the top, not just by size, but by the physical record of its victories, written across its own skin and bones. Beneath the Southern Ocean, predator and prey are locked in a contest shaped by millions of years of adaptation. The giant squid and its formidable cousin, the colossal squid, have not survived by hiding. Their defenses are as remarkable as their hunters' ambitions. The giant squid's eyes, nearly 30 centimeters across, are the largest of any animal. These enormous eyes do more than pierce the darkness. They detect the faintest shimmer from bioluminescent plankton disturbed by a sperm whale's approach. Even at distances up to 120 meters, a flicker in the gloom can mean the difference between escape and capture. When flight is impossible, the squid's arsenal comes into play. Along each tentacle, the giant squid wields sharp, chitin-lined suckers. The colossal squid takes this further. Its arms are equipped with swiveling hooks, some straight, some barbed, each up to 5 centimeters long. These hooks, with tensile strength rivaling bone, are built to latch on and tear. In the chaos of a struggle, they gouge deep wounds, leaving scars that map the history of these encounters. For the whale, every hunt carries the risk of injury or blindness. For the squid, every weapon is a final stand. Their battleground is a shifting frontier, plunging more than 2 kilometers deep. The squid's soft, ammonia-rich body drifts effortlessly, conserving energy for sudden bursts. The colossal squid, heavier and more robust, haunts the Antarctic depths, rarely seen except as remains or scars. Each adaptation, giant eyes and bone-strong hooks, marks a relentless contest. Neither side claims lasting advantage. Every scar and every beak tells the story of a struggle where survival is won by adaptation, not strength alone. Right now, deep-sea creatures are evolving faster than we can study them, reshaping ocean dynamics in ways we barely understand. As climate change and human activity push ecosystems to the brink, every adaptation below reflects a warning above. The true rulers of the deep aren't just monsters, they are signals. Our survival could depend on whether we heed what the abyss is trying to tell us. What's your take? Drop your thoughts below.